Good morning, everyone. Thank you for joining the Docker Enterprise Edition webinar. A few housekeeping items before we get started. As a reminder, this session is being recorded. A copy of the session will be sent out after the webinar. We'll take questions throughout the webinar, so when you have a question, please type them in the QA window as they come up, and we will address them. I will now turn things over to our speakers, Jenny Fong, Product Marketing, and Moni Salam, Solutions Engineer for Docker.
Thanks. Let me grab the controls, and I will start sharing my slides. Okay, so thanks everybody for joining today's webinar, Docker Enterprise Edition. As Melanie mentioned, this session will be recorded and available for you later today, but please do use the Q&A and chat windows, and we'll be monitoring throughout. So let's get started. I'll say hello. My name is Jenny Fong, and I am a Director of Product Marketing here at Docker. I'm also on Twitter as TechGalJenny.
Hi, everybody. I'm Moni Salam, Solutions Engineer. No Twitter for me. One of the few millennials without a Twitter.
And Moni will be providing a demo of Docker EU for us later in this session. So let's just start, and I'll share that, overall the IT landscape is changing rapidly. Companies like all of yours across all different industries are recognizing that there are major shifts taking place. The first one is in app modernization. So companies see how microservice app architectures can be easier to upgrade and allows companies to add more features on a more regular basis. They're also more scalable and can be more highly available as well. So we see a lot of organizations investing in how they're going to be updating their apps. But second, everyone understands the value of public cloud, and so more companies are concentrating how they can achieve not just a public cloud strategy, but a multi-cloud strategy. They want to be able to easily migrate existing workloads to the cloud for that financial flexibility, but they also want workloads to be portable across environments or multiple clouds. So, and then the last one is many organizations are embracing DevOps practices. They're doing this to achieve faster time to market and improved agility. And these priorities do overlap. DevOps is sometimes easier in the cloud than on-prem. App modernization goes hand in hand with continuous integration. So overall, organizations like yours are exploring how they can achieve these strategies. But the challenge is that many of you, especially in the large enterprise organizations, are dealing with a lot of diversity in your data center. You may have both physical and virtual servers, even some mainframes. You're looking at both your on and off-prem strategy. You probably have a mix of Linux and Windows workloads, and maybe a mix of traditional and new microservices workloads. So the question is, how do you deal with all of this diversity while still enabling your organizations to look at cloud, DevOps, and new application architectures at the same time? So what we've found from talking to customers and working closely with them on their container journey is that it really comes down to 3 steps. And each of these steps are designed specifically to work well with that diversity that's inherent in your organization. So it starts with a secure base. As we mentioned, the world is diverse, so if we containerize all the workloads, containers generally work very well to democratize your applications and infrastructure. And so Docker works with both Linux and Windows workloads, and these containers can be deployed on any infrastructure, whether it's physical, virtual, in the cloud, or in your data center. So containerizing allows you to create this kind of uniform platform that you can move workloads seamlessly across. And this is delivered through the container engine, which forms the secure and reliable foundation to all of our Docker editions. This is the core technology for running containers on any infrastructure, whether it's a single host or multi-host Swarm cluster. It includes how containers work with the storage and networking resources, and includes container orchestration. But running containers is really just one part of the equation. You also need to think about how you manage a container through its entire life, from a developer's laptop all the way to the production environment, and then ongoing maintenance after that. So for this, there needs to be some sort of connective tissue between your developers working on code and the IT operations team who's expected to run and manage the apps. So the goal is to look and operate more like a software supply chain, where the input is code and the output is the application running in production. That means having tools and processes in place like a secure image registry from which developers can push and pull images, and a control plane that lets operations teams monitor and manage and deploy containers across a heterogeneous environment. An enterprise organization also wants to make sure that this entire supply chain is secure from end to end. So Docker has focused on a couple of capabilities that help ensure the validity and the security of your images. One method we enable is the use of digital signatures, and this helps to validate the source of a container, who's worked on it, and help to trace it to the source if needed. And the second method is image scanning, and this is where you take an image and you can compare it against a database of known vulnerabilities at the binary level. Moni will highlight some of these capabilities in the demo. So when you want to build that secure supply chain, you'll need something more than just a container engine. You'll need an integrated lifecycle management solution that includes things like policy and access management, image signing and scanning, and private registries. And this is all delivered through Docker Enterprise Edition. But we also know that this doesn't happen in a box, so we work with a broad set of partners to ensure that Docker works well with other solutions that you're already using. One way we do that is by certifying these third-party solutions. So when you use Docker Enterprise Edition with Docker certified infrastructure or images or plugins, you can be assured that you can get support if there are any issues that arise. So here's a sample of some of the different certified partners we work with. And specifically with Docker Enterprise Edition, we work closely with the infrastructure vendors like AWS or Azure, Windows Server, et cetera. And we make sure that our solution integrates tightly with those infrastructure platforms. You can find out more about all of these certified partners in the Docker store. So this is what we mean by containers as a service. It's a single software supply chain that allows our customers to improve the efficiency, portability, and security of their entire IT environment. It also empowers you to pursue your IT initiatives like the multi-cloud or DevOps or app modernization projects in a technology-agnostic way. So let me share one story coming out of DockerCon 2017, which was just a few weeks ago in Austin, Texas. MetLife was part of our keynote on the second day, and they talked about how they've used and leveraged Docker EE to really innovate across their almost 150-year-old business. So they're leveraging containers to help modernize their existing workloads and to be able to deliver a modern experience to some of these subsystems that have existed for decades. Some of the code that has been around for 30 years is still in operation, and so they wanted to be able to provide a more modern experience accessing that data. What's happened is since they've implemented Docker EE, they've seen some immediate gains in their data center utilization and efficiency, so that they're seeing increased resource utilization up to 70%. And they're seeing the ability to handle increased traffic demand by moving workloads to the cloud very simply because it's already been containerized. So if you want to learn a little bit more about MetLife and how they're leveraging Docker EE, please make sure to watch the playback from DockerCon 2017. So now let me just describe in a little more detail our Docker offerings. Docker container technology started as an open source framework, which is now called the Moby project. So the MOBI project has thousands of contributors and an active community that includes employees from Docker, ecosystem partners, as well as strong contributions from unaffiliated individuals. Now, from the MOBI project, Docker delivers 2 products. Docker Enterprise Edition is a set of commercially supported subscription-based products intended for production deployments and enterprise customers. And Docker Community Edition, which is a free community-supported project intended for small teams and software development and test. We also have a concept of an edition, which both the Community Edition and Enterprise Edition includes. So this is where we work specifically with an underlying platform, whether it's your MacBook, Windows, or Linux laptop, or a cloud provider like Amazon Web Services or Azure. So these editions are designed to integrate natively with that underlying platform, making it much easier for new users to onboard and become productive with Docker. So for example, Docker for AWS is installed with a CloudFormation template that configures Docker in Swarm mode automatically for you. So, and it gives you immediate access to other AWS technologies. But there is also a core difference between Community Edition and Enterprise Edition based on their intended purpose. So large organizations or organizations running containers in production want to be able to validate their deployments and get support if something happens. So Docker provides pre-validation on integrations to different infrastructures, containers, and plugins. These get a Docker certified badge and as having been validated to work with Docker Enterprise Edition. So again, when you have an issue with the certified partner, then you're sure to get support to help fix the issue. With Community Edition, support will come from the community. So here's a comparison of all the Docker subscription offerings. In addition to the differences in support, note that the Community Edition also carries a shorter maintenance period. That's how long Docker will keep issuing patches and hotfixes to a previously released version. So note that within Enterprise Edition, there are 3 tiers: Basic, Standard, and Advanced. EE Standard and Advanced introduce some new capabilities that are not available in the Community Edition, specifically the private registry solution called Docker Trusted Registry, or DTR, and the Universal Control Plane for securing and managing clusters and containers. EE Advanced additionally offers image scanning and vulnerability scanning, and when a Docker EE customer will also choose between business day or business critical support. With that, I will now pass it over to Moni for a demo. So let me stop sharing.
So there's one question that came in that I think is a great question to address at the end.
Okay.
Great. Okay. Share my screen here. So I believe everybody can see my screen. Please share something in the chat if you cannot. You can see it?
Yeah.
Great. First off, before we start, I'll just touch briefly on the different components that I'm about to demo. Docker Enterprise Edition consists of three moving parts. One is the Enterprise Engine, which is essentially does all the heavy lifting from a container runtime perspective. So provisions containers on nodes, gives them access to compute resources, to the network resources, etc. Then there's the Universal Control Plane, which is basically the orchestration tool, orchestration and management tool built upon the open source clustering technology called Docker Swarm. So if I want to orchestrate workloads across multiple Docker engines and manage them as one entity, that's Universal Control Plane, and that's actually what we're looking at right now on my screen. The third component is the Docker Trusted Registry, which is a container image store specifically made to store container images, and it has a lot of built-in features and capabilities to aid in some of the workflows and processes that Jenny shared as part of her slide deck. With that what my demo is going to entail is essentially some flyby items on the different products. I'm going to demo a specific use case around continuous integration, continuous deployment, basically demoing from kind of the developer laptop how to propagate basically a Docker image, Docker container onto basically this universal control plane system, and then also touch on some production-grade features at the very end, and then hopefully answer as many questions as we can. So what we're looking at right now is basically the one pane of glass dashboard to manage basically everything container related. So as I said, this is the universal control plane dashboard. So from there, I can manage everything to do with containers. So services, which are basically operationalized containers that are load balanced and service discoverable out of the box. The container workloads themselves, I can get a insight into different images I have loaded in my system. I also can look at things from a machine perspective. So if you're looking at what I'm running now for this demo, I have a 4-node cluster, and essentially there's different things I can do to basically aid me in A, management, or B, in actually deploying workloads. So the first thing I want to call out is this concept of node labels. And this actually becomes a pretty vital concept if you're running a hybrid Windows and Linux cluster, or if I want to manage dev, test, QA, and prod environments all with one pane of glass. So an example node label could be environment, write an environment label, and I can label this prod or dev, and then basically steer workloads accordingly to those different nodes. So that's just one thing you can do from a management perspective at that layer underneath the Docker engine. A couple other things to look at is container networks, right? So networks specifically built for containers and that containers leverage. So there's different options there. We also have basically a driver plugin interface, so you can find on the Docker store certified plugins made by Cisco, Weave, right? Different network vendors that can basically extend the networking functionality of a container environment. So one other thing, volumes, right? So that's the persistent data structure if a container needs to persist data, and that basically is stored on disk. And then there are different instrumentations that you can build in to kind of export that data off box, integrate a database, etc. And this is once again something you can find on the Docker store. You can find other drivers created by different vendors and plug that right in. One more thing to kind of point out is this concept of a secret. So a secret is essentially something that an application needs to access that is sensitive. So that can be a username or password for a database. It can be an API token. Essentially, this secret is stored on the back-end Raft data store. So the UCP managers talk in a protocol called Raft, and they store all the metadata in this Raft store that is encrypted. And then also the secret, when a service actually requires that secret, at runtime, basically that secret is delivered over TLS. And I'll kind of demo what that might look like from a workflow perspective as well as kind of a workload perspective. So with that being said, I'm going to kind of go through the CI, continuous integration, continuous deployment use case. So what I have running here, I have a bunch of different services. One of them being this, ironically, this app that I call Tweetly. You'll kind of see why in a second. One thing I want to point out here is that these services, which are basically containers that are load balanced out of the box, I can actually expose, basically I can create a service, expose a port, and that port gets load balanced cluster-wide. So across all 4 of those nodes I showed you, they each essentially have a tiny forwarder at this port 3001, or I can actually make it a layer 7 forwarder and have them forward on this UCP.tweetly HTTP header. So you have 2 options there. Relatively easy to integrate right into really any environment, no dependence on any infrastructure to get something like load balancing or any service discovery or anything like that. So if we see what this app does, right, welcome to cluster test. I'll change this guy in a second. So essentially, what this app does is it allows you to tweet and say, hi, I deployed my first container. Essentially what I'm going to do here is use my Docker for Mac tool and essentially modify this container image, push it into my GitHub repository, which will then kick off a continuous integration build, which in my case is Jenkins, but this is very pluggable. Really, any continuous integration tool can be leveraged here, and we'll kind of dive into what that tool actually does. But Jenkins is running as a container, as you can see here, running as a container managed by the system, and kind of doing its own orchestrating cluster-wide. So without further ado, I'm going to show you really quick what does a Docker image look like for those that might not be familiar, and what actually creates this application, this Tweetly application. So a Docker file is basically a blueprint for how to build a Docker image. If you look at it at face value, it kind of looks like almost like shell commands, but essentially they all follow the same structure. There's a base image. So if you actually look at a container, a container without any code inside of it is just a process and an empty file system. And then once you actually have this from statement, you actually start to populate that empty file system with basically the source code needed to run, for example, in my case, Nginx. This can be Ubuntu, this can be Alpine, this can be Java. And essentially it gives you a substrate to start off with so that you can start adding your own source code on top of this kind of boilerplate image. So Nginx, for those who aren't familiar, it's a web server, it's a layer 7 forwarder. It's a really useful tool. So what I'm doing here is I'm taking the Nginx base image, that source code that gives me that Nginx functionality. I copy this index.html file basically from the current working directory from where I run the Docker build command, which I'm going to do in just a second here. I expose port 80 and 443 on the container because containers have their own network stack, and then I start the Nginx server. It's pretty simple. So what I'm going to do here is, since I know exactly kind of how to modify this app, I'm going to open up this file, and I promise this is the only thing I'll do on the command line, so please don't fall asleep on me. I'm going to go ahead and modify this image. Make sure that Git picks up the changes. I'm going to add, or actually what I'm going to do is I'm going to test it locally first. So I'm going to Docker build -t, which basically means tag it. So this is like how you would version an image. I'm going to tag it as webinar, and then I'm going to say build it from the current working directory. So it just basically tells it to look for the Docker file in the current directory we're in. As you can see, it will run through basically each line of the Docker file. Each line basically adds a layer of code onto the underlying system. You see it's successfully built. Now we're going to test it locally using the Docker for Mac edition. So basically, there's the actual Docker for Mac has APIs built in, so I can integrate with the X-Hive virtualization on the Mac, so I can have like a seamless testing experience. As you're kind of about to see here. So Docker run, -d means daemonize it, run it in the background so I can get my shell back. -p, which is where that virtualization integration comes into play, forward the ports on my Mac, port 8080 to port 80 on the container, because that's what's exposed here, as you can see in the Docker file. And then we say run the webinar image. So first thing you notice is it spits out this long checksum, which is actually really important because we can actually audit and check that in DTR later when we push this image. So what we'll do is we'll check, make sure the container's running. We see it's running at this location. So if I go to my localhost 8080, we see, okay, cool. So I've basically changed the app locally. I tested it, validated it works, but now I have to actually push it right to where where it's externally accessible behind my host name, and it's load balanced and all that good stuff. That makes a workload a real workload. So let's do that in a CI pipeline. So what I'm going to do is push this thing to GitHub. So git add, and I'll commit it, and this will be the last command line thing we do. So it'll push, and I will flip over to Jenkins and see what's actually going on here. So log in. So we see, right, I have basically a log of all the builds, successes and failures of all the builds that Jenkins has gone through. So if we come in here, I'll show you what's actually about to happen. So, right, I have Jenkins basically linked to that GitHub URL that I showed you earlier, and basically once the change is picked up, it'll execute this job. So what does this job actually do? Basically the same exact thing that you saw me do on my laptop. And that's kind of what makes Docker so attractive, is really it's one set of tools, right, one set of APIs for all your systems to use, right? So your developers, your operators, and then also the systems in between them that actually leverage Docker and help promote different artifacts, right, from system to system. So I'm going to go ahead, I'm going to build and tag the image differently so I can push it into DTR. And then I actually do a couple of things that allow me to orchestrate commands cluster-wide. So basically I point to a certificate chain that's associated with the administrator user. And every user basically in the system has one of these. So there's cryptographic identity verification there and authentication. So basically, right, this is for controlling privileges as to what commands can be executed, what API endpoints can be hit for a given user. Then also I can sign an image using the certificate as well. And that just basically adds to the end-to-end image provenance, auditing. There's policy you can enforce around that, which hopefully I'll get to at the end, barring time. And then, so I build it, I tag it, I basically configure Jenkins to, securely orchestrate and push, and then I basically push into DTR. And then kind of one of the most important steps is I run this Docker service update, which basically will update the image as it's running behind that host name, right? That host name that I configured, without me having to do anything, right, to kind of to make that happen. So I didn't have to bring down the service explicitly, reconfigure the load balancer, right, do anything from an operations perspective. So that's what's going on here. Click out and see. Okay, we see the job ran, number 19. Let's go ahead and look at the output. So we see, right, the same exact steps ran. We rebuilt for, basically using the Dockerfile command. We go in, we do, right, we configure Jenkins to securely push. We run the Docker service update command. And if we come in, let's see, make sure it's up and running, and we refresh, fingers crossed. Okay, cool. And we see that the app has updated, right, 0 downtime deploy. So that's one use case that's kind of a DevOps CI/CD flavor. You don't always necessarily have to have Jenkins do that Docker service update, right? That's just kind of if you have the entire end-to-end system automated, right? Most of the time you'll find Jenkins run a bunch of unit tests, smoke tests, right? Whatever you guys kind of use in your deployment model, and then push into DTR. And then basically that's where the operators take over. So what I'm going to do is I'm going to flip over to DTR and kind of look at some different things that the DTR has, and then also look at what we just pushed and what happens when we push that image. So DTR is a application managed by UCP. So actually, really quickly, if I go and go look at all the applications that I have under management, I see DTR as one of them. So DTR has its own UI. It is a microservice application consisting of 10 containers, one of them serving up the UI and API, and basically just providing the functionality of this application. So really quickly, if we look, I have basically a couple things going on here. So you know, I have basically a unique ID generated for my image. I see the tag, like, but you know, basically the tag of you know, basically just allowing for a further versioning of a given image. I see who pushed it, and then also a really important security check is I see basically the outcome of a vulnerability scan. You can see, right, I didn't really use a good substrate, or I added some, you know, some potentially vulnerable code to DTR, but that's something we'll have to mitigate later. So we'll look at the details of kind of what does this image scanning technology do. So essentially, when I push this code, DTR does a binary level scan that generates a bill of materials. And here's that bill of materials that basically it pulled out of that Tweetly image. So I can actually look at things in two ways. I can look at the outcome of the scan in like a container-y kind of view, where it actually pulls out the different image layers and shows you, okay, you know, every layer of code is basically additional attack surface, and then here's kind of the outcome of what that layer actually added. Or I can look at a more kind of typical view by looking at the different, you know, system components and their different vulnerabilities, and I can actually click and you know, get some more information on what that vulnerability is, who posted it, if there's any way to remediate. So one other thing I think to point out in DTR is this concept of a manifest, right? So remember how I said the checksum, basically, you know, there's a checksum generated off of the contents of a container file system, and you can actually get this from the API, you can get this listed out, but this is just a great way to basically verify image provenance. It's good for auditing, things of that nature. So this is all kind of part of the I guess the end-to-end workflow. One thing to point about DTR, there's basically different storage options. So this is kind of alluding to the agnostic view of where you want to run DTR. So storage options for AWS, Azure, OpenStack, Google Cloud, things of that nature. So okay, I think kind of pivoting to a more production kind of use case scenario. So I have this other application here, and we'll take a look at what this actually does. So part of this application, I have two of those layer 7 hostname routes, and one is called pets.docker, and it's Docker Pads, so essentially Pets as a service. And you'll see why in just a second here. So one thing to point out is this container ID. So I actually just kind of, eventually I'll get a different, there we go. I get a different container ID, and I see that my requests are getting load balanced on the back end here, right? And then also, let's go ahead and see. So say, Jonathan, and you guys will see why I'm doing this in just a second here. Right. Okay. So right, it's cute means get served up based on the vote that I put in. And the reason why I'm doing this, here, let's do one more. I'll fill one in for Jenny really quick. And let's see. Okay. So now I'm basically going to leverage the Docker secrets feature. So what is this? Why I'm using this secret basically just as a login, and you can see it's actually in my autofill. So when I log in, I actually can just see the outcome basically of the two votes that I just put in. Right, kind of a toy app, but just one way that you can leverage Docker secrets. So how did I actually basically A, create the secret, and B, essentially reference that secret when I launch the application? Because the workflow is as follows. Essentially, an operator or the user of this tool essentially would come in, create a secret, right? It's basically a key value. So, secret 1, and then, right, I actually say what I want the secret to be, and that's the last time it'll actually be in clear text. So then what I do is either on the command line or in a Docker Compose file. So Docker Compose, for those who are not familiar, is a way, if I have an application consisting of multiple containers, it's a way to launch them all at once and basically bootstrap them with all of the necessary resources that application needs to run. So for example, if the containers need to speak to each other, I can join them on the same network in this compose file, right? And basically there's a lot of things I can do in the compose file. One of them is actually attaching them to that layer 7 infrastructure that allows it to, each service to basically have its own unique host name, be load balanced. I can configure health checks. I can pass in environment variables. One of the most important things, right, is actually reference and say, hey, this service requires this secret, which in my case, right, for this secret, this would be secret 1, right? And basically, I make that, that secret is basically stored in the default location of run secrets, and then I can actually just pass it to the application either through an environment variable or have the application read that actual file. So there's this is kind of what a compose file looks like. This is an example, basically, in the very beginning, I showed you those node labels, right, where I used the environment node label. There's actually built-in labels to the system, one of them being the role. So basically, I can steer workloads to run on managers, I can steer them to run on workers. And there's actually one node.os where I can steer it to run on Windows, and I can steer it to run on Linux, because you can actually run Windows and Linux nodes in the same cluster. Let's see, okay. I think a good time now to maybe answer some questions. Have there been a lot of questions?
Yep, we are. We're getting a ton of questions. I'm going to just kind of throw them at you. I've answered some of them, but there's a couple of questions about Windows support.
Sure.
Or Microsoft app support.
Yeah, so specifically are we talking about like runs, like image support?
Running Windows containers and also managing Windows hosts.
Sure. So running Windows containers. So first off, Windows Server 2016 actually comes with, out of the box, the Docker engine natively running basically on the native Windows kernel. So no virtualization involved, right? There's actually a pretty deep engineering effort between Docker and Windows to make that happen. Essentially, there's two kinds of, actually there's 3 ways to run Windows containers. One is kind of in a Hyper-V mode where, you still have to run a Windows container on a hypervisor. One is basically it's called Windows Server Core, and that's for older .NET versions or older .NET framework versions, and more of like a legacy approach, I would say. The other is it's called Windows Nano Server, and that runs basically IIS and .NET Core, right? .NET Core framework. So that's kind of your newer greenfield modernized Windows workloads. So kind of 3 ways to run those on a Windows machine, and then also, right? So Docker Swarm is the orchestrator, and you can run Docker Swarm and manage Windows workloads. Basically, with Docker Swarm alongside Linux workloads as well. So nothing extra, right? Nothing special to manage Windows nodes, I guess is the answer.
Some follow-up questions there. What versions of Windows? So Windows Server 2016.
Windows version Server 2016, and then on the development side, you can run Docker for Windows on Windows 10, I believe. And there's all the flavors there. Hyper-V containers, right? All the Nano Server, Windows Server.
There is a question about how you take a .NET app and make it into Windows into a container. I'll just make a comment there. One of the things we announced at DockerCon is a new service called the Modernizing Traditional Applications, so MTA for short. This is a service that you can work with one of our partners, which includes Microsoft, HPE, Cisco, as well as Avanade, to help leverage a tool called Image to Docker, and that helps convert your .NET apps into a container. So there's some more information on our website if you just go to docker.com/MTA. There's some questions about
there was one question around concern for CE and non-prod and then moving EE in production. I just want to answer that one because that's a good question. So there shouldn't be any concern. The APIs, basically the APIs and the code base will never change from CE to EE. Really what EE has is additional APIs basically to extend the functionality of CE, basically for management, security, and just, kind of an enterprise ecosystem. So moving from, we have a lot of customers who have CE non-prod and basically EE and prod, and the actual APIs don't change, right? The engine APIs are the same. Really, the only thing is just kind of the additional UCP, right, and the additional orchestration APIs that you wouldn't really have in CE anyway.
There's some questions around how we integrate with other solutions like Kubernetes and Amazon ECS.
Sure. So Kubernetes, so they're a little different. So Kubernetes is an orchestration tool. It's a great tool. Basically, you can run Kubernetes with Docker. You can actually buy. There's a configuration where you can get supported Docker engines and run Kubernetes. But essentially, Kubernetes is an equivalent to this tool that you're seeing here. Kubernetes does not use Docker Swarm though, right? So from a Docker perspective, it's considered a non-native solution, but the architecture is a little different, right? So instead of running containers necessarily, you're running a workload termed a pod. And they're just different, right? So different use cases, they tend to be aimed at different use cases, and definitely lends itself for a deeper discussion, right? Not necessarily, I think, for the scope of this call, but there's definitely, it's a Venn diagram, a lot of similarities, some differences.
Specifically, can DTR run with Kubernetes?
It can.
Yeah. And on ECS, same thing. ECS supports Docker containers,
yes,
but it also leverages its own container orchestration.
Exactly. So no Swarm, ECS, and I think the Docker. So in each case, is the Docker version that they support. I think is not necessarily like one, the latest. So yeah, the Docker version can vary as to what they support.
Okay. And a question about Google Cloud support, and that is in beta right now, also announced at DockerCon, so
sure.
We can look for that. There is a specific question around, this was a good one, about the experience of trying Docker EE. Mm-hmm. It's very hard to kind of test that in a cloud scenario. I just wanted to make the comment that we are working on some solutions to help customers kind of play with Docker EE in a full-blown, cluster?
So we have a couple options. We are going to roll out essentially what we call like basically a hosted trial. So it's basically, you get to spin up basically a cloud environment consisting of Docker Data Center. We host it for you. It's a very specific workflow. That we basically try to get you to go through and kind of leverage some applications that you guys create and kind of get the look and feel. We also have there's some CloudFormation templates that we produce that if you were to obtain a trial license, which is very possible, right? That's one way to kind of test it out in a cloud scenario. But there are many ways to get it done. I think engaging the sales team is one way of kind of finding the best way forward on that. But yeah, those are probably the best options to trial it in a cloud
scenario. Okay. Some of these would take us an entire webinar to answer, but can you give a high-level overview of routing mesh and an example of how namespaces work?
Okay, so routing mesh, basically there's a kernel layer 4 load balancer and forwarder called IPVS, and this is in the Linux domain. And essentially when I expose is my screen still being shared? So hopefully everybody's still kind of looking at my screen, but when I'm just gonna, if you see I'm in the UI, basically I'm running through how you create a service in the UI, and I'm just, for the purpose of right now, I'm just kind of blowing through some of this. But this is, the publish port is essentially where all the networking magic happens. So basically when I publish a port, let's say like the port, an internal port refers to the port that the container is listening on. And I say, let's say 80, right, for a web server, and automatically assign a port. Whatever port is automatically assigned, like for example, Jenkins is port 3000. They're basically, every node will have a listener at port 3000 with a requisite forwarding table of where the actual instances of that service are running. So it's a distributed, basically think of it as a distributed layer 4 forwarding table, and then essentially the same thing with a layer 7, or with this add host name route. I hope that yeah, anything deeper would probably take too long, but yeah, IPVS is what does all that magic. It's a layer 4 kernel. And then the second part of that question.
Okay. There's routing mesh, and it was
namespaces.
Namespaces.
An example of namespaces.
Or labels, because I know that question came up. Yeah.
So there's couple things around namespaces. So first off, there's the container namespaces themselves. So when containers, like let's say 3 containers on the same Docker engine are separated by namespaces, right? That's just the underlying Linux technology. So that means they have their own addressable memory. They can't see the other containers, can't see their addressable memory, right? That kind of thing. Then there's actually in the context of that Pets as a Service app that I showed you guys, and this is something that's built into Enterprise Edition, is basically I can attach these names, this basically namespace variable that's a system variable, to basically isolate workloads from each other. So if you see here, I can attach this to, you see it's attached to this service, and then I can also attach to the network that service will access, the volume that service will access, and then the secret that service will access. So 4 things I can add into a namespace, and that basically isolates it from everything that's not in that namespace. So that's basically just ways that you lock down the system, keep workloads from tripping over each other. So for example, let's look at the network pets. We look at the back end here, and we see, right, that it's basically inside of this namespace here. So basically a service, for example, my Tweetly service cannot join or cannot even see this network, or the volume. So basically it's just ways of isolating containers from each other.
Okay. I don't know if you noticed, does the security scan cover CIS benchmarks for Docker images?
So no. So the CIS benchmark tool is basically a configuration checker. This is what I like to think about it. So I'm not sure what that exact question is aimed at, but the benchmark tool is kind of different. It's more of checking the configs of something like SE Linux or AppArmor, right? The actual runtime configuration, the runtime security configuration from a Linux perspective. It's a good tool, but yeah, it's not really, it's aimed at something a little different than the image scanning.
And I think this will be the last question we answered, but it's what makes Docker EE different from Kubernetes or Mesos?
I'll answer this one. So basically, I think one thing to point out is Kubernetes in itself is an open source project, and then you have different forms of Kubernetes that are packaged and resold. So what I'm going to speak to is the open source Kubernetes. So basically, Kubernetes is basically a fully comprehensive project that requires a lot of integration and requires a lot of expertise, right, frankly, around containers and how to use and leverage containers. A lot of things like secrets management, and a lot of different security things like that extended namespace concept that I showed you don't really, require a lot of extra work to integrate into Kubernetes. But that being said, right, Kubernetes allows you to really fine-tune your environment, right? And I like to think of it as, if you want to, it's like driving Formula One, right? Kubernetes, if you're a Formula One driver, you need to really, really fine-tune every aspect of the way that your containers run, and it's not just like a web app. It's some crazy application with really specific requirements around how you manage it and specific networking protocols. Then that's a Kubernetes thing. Mesosphere is I would say it's a great tool, but it's a all-in-one tool for managing containers, Hadoop workloads, virtual machines. It's not necessarily built with containers as a first-class citizen, so all that being said, you can run Docker EE with those tools, right? So that the question might not be, it's really a Venn diagram. Like you have to compare the orchestration against Kubernetes and the orchestration against Mesosphere, right? And it's really like kind of a native experience versus how much do you want to fine tune, and that is a very deep discussion though. So that's the high level.
Okay. And I think that is it. So if we missed any of your questions, apologize, but we will make sure you guys all have access to this presentation and this recording, and we have a slew of other webinars coming up. Right before we go, let me share some final words. And yeah, I'm going to grab the ball. Sorry. Actually, can you pass it to me? It doesn't.
Yes.
Yep, I've got it. And let me start sharing my screen. And so thank everybody for joining us today. A couple of next steps for you guys if you want to learn more. Of course, go to our website at docker.com. There's more information on Enterprise Edition there. There's also some self-paced and instructor-led training, as well as the blog. If you want to try and start playing with it, there is places to download Docker for Mac, Docker for Windows, as well as those other Docker editions. You can also go to the Docker store, find all that there. And then the last thing is to make sure to join and participate with our community. We're very proud of our community, and it's very active. You can find a local meetup. And if you're interested in being in Copenhagen in October, you can join us at DockerCon Europe. Registration is open today. All right, with that, thanks everybody for your time, and we hope to talk to you again.
This does conclude our webinar, and just a quick reminder that the session was recorded, and a copy of the recording will be sent to you. Thank you, everyone, and have a great day.